Hello, Lana. We are still moving on with matrices in Form 3, and we've done quite a number of things. We started by introducing ourselves, looking at the basics, the elements, the rows and columns and whatever, even types of matrices and orders. And now today, we want to look at a very interesting part. This is an identity matrix. We also look at the determinants and maybe the inverse, of course, of a 2 by 2 matrix. When I was giving you the types of matrices, I think I forgot a little, but I knew I would touch on it in this lesson and even in the last lesson, because we have one more video to go so that we do away with the whole chapter matrix in Form 3. We talked about a null matrix or a zero matrix. We talked about a square matrix, and now there's another type that we shall introduce, one or two. We have what we call an identity matrix, which is also called a unit matrix in this lesson. And we shall also talk about another one called a singular matrix. So walk with us, walk with me, as usual, Wilfred Momanyi Onkangi Haifedi Kiongozi. And actually, because we are in 2023, I still wish the Form 4s of Lanet Secondary School, class of 2023, all the best. We shall get very many A's. And of course, across the country, I don't sideline anybody. Everybody success in your KCSE. That is a few weeks away. Now, we can write the following: an identity matrix. An identity matrix. An identity matrix. This one is also called a unit matrix. Also called a unit matrix. It's also called a unit matrix. And this is a square matrix which has one in the main diagonals. This is a square matrix. This is a square matrix. This is a square matrix which has one with one, I mean that one in the main diagonal. In the main diagonal, something new there. In the main diagonal. In the main diagonal. I have introduced something new here, and I will tell you what that means. So and zeros and zeros. Actually, I should say ones. Yes, ones and zeros in the other diagonal. In the other diagonal, and zeros elsewhere. This one elsewhere can also mean in the other diagonal. In the other diagonal. So I want to give you an example and quickly describe what diagonals are in a matrix. If we have a matrix A, B, C, D, now that I have introduced the term diagonals, A, D is the main diagonal. So A, D is the main diagonal. So the otherwise or elsewhere is B, C. So B, C is the other diagonal. That one is well sorted. So an identity matrix will have in the position of A and D, we shall have 1, 1. So an identity matrix or a unit matrix will have 1 here, and of course another one at D. Then the other values, the other elements are zeros. 0 here, 0 here. This is a 2 by 2 matrix, which is a square matrix, 2 rows, 2 columns. So that is what we call an identity matrix. The main diagonal can also be called the principal diagonal. Principal diagonal. Principal diagonal. So that one, I hope you have it. Then we can denoting an identity matrix. We denote it. This matrix is denoted by capital I. Capital I stands for an identity matrix. So if, for example, you're multiplying an identity matrix with another matrix, so you will say I times that matrix. Of course, there is something we shall talk about. This matrix, the identity matrix, multiplied by another matrix. An identity matrix times a matrix equals a matrix. So an identity matrix is like one. Is like one, because if you multiply it by a matrix, you get that matrix. It is like one. An identity matrix multiplied by another matrix, the answer is that matrix. That's a point to note. For example, we can write our identity matrix 1 0 0 1 like this, then multiply it by A, B, C, D. We want to confirm that when we multiply these matrices, the identity times this matrix, yeah, this one is our matrix M. You can write it here, and then this is I, the identity. Let us follow the procedure of multiplication. You will realize that we get A, B, C, and D. So 1 times A is A, plus 0, row, columns. 0 times C. This times this times this. 0 times C is 0. The other far end, 1 times B is B, then 0 times D is plus 0. Now the second row, 0 times A is 0, and then of course 1 times C is plus C. Then the last one, row, last column, 0 times B is 0, then 1 times D is D. What happens? 1 plus 0 is, A plus 0 is A. B plus 0 is B. 0 plus C is C, and 0 plus D is T. So we have confirmed that an identity matrix is like 1. Because if you multiply it by another matrix, the answer is that matrix. Well, you have understood that. The next part, determinant of a 2 by 2. Determinant of a 2 by 2 matrix. Determinant. This is something new again. Determinant of a 2 by 2 matrix. So in this case, we shall consider matrix M, which is equals to A, B, C, and D. Consider that one as our matrix. The determinant is gotten by the determinants of this matrix is gotten by the determinant is gotten by the products of the elements of the main diagonal. Products of the elements. Sorry, by subtracting, how to put it in a language that you can understand, is gotten by the subtracting the products of elements of the main diagonal. Sorry, I want to change this. We subtract the elements of the other diagonal. From the product from the main diagonal. From the products of elements of the main diagonal. I want to put it in a language that you can understand. That is, the products of the main diagonal elements minus. So this C times B is subtracted from A times T. So we shall say AD minus BC. You can say DA or whatever you want to say. This is how we get the determinants. An example. These are now the points to give you marks in this question. Given that, if you're given, maybe find the determinant, we're making it brief. Find the determinant of matrix A. Matrix A, which is equals to 3, 2, and then we have 4, 5 like this. We make it brief. Solution. What we have already said is you first of all identify the main or the principal diagonal. So product of elements of the main diagonal, 3 times 5. So determinants, I write DET, is equals to 3 times 5, put the bracket, then minus the other diagonal, 2 times 4, 2 times 4. So what we get here is 15 minus 8, which is 7. So from there we go to something else. After determinant, we go to inverse of a matrix. 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 We also give an example. Consider matrix B, which is equals to 3, 2, 4, negative 1, like that. Then, if you want to look for the inverse, you first of all look for the determinants first, because already I have taught you how to do that. Then you go to the inverse. This is coming. So determinant, I identify solution here. I identify the main diagonal first. So the product of elements of the main diagonal, 3 times negative 1, put the brackets. Then minus 2 times 4. 2 times 4. Again, you put the brackets like that. So what happens is, you will have, this is negative 3 minus 8, which is negative 11. That is the determinant. So the first step of looking for the determinant, well gotten. Product of the elements of the main diagonal minus the product of the other elements of the other diagonal. So the next thing now, the new thing now in this is the inverse. In the inverse, inverse can be denoted like this way, just like the reciprocal. So this one, when I put a power negative 1, this one is the inverse of matrix B. So I can denote it as B raised to power negative 1. What we do here, we will say, suppose our matrix is A, B, C, D. What we do is we say 1 over determinant that we found in our first step, then multiply by some few changes here. We shall make a few changes on the matrix that we have. This is a dummy. So we shall change this way. Elements of the main diagonal shall be interchanged in position. So we shall start with D going there and A coming to position D. So we shall have D here. And then A going to where D is. Those are a few adjustments and changes we make on this matrix when you're looking for the inverse. And then the other B and C, they maintain their position, but you introduce a negative. So minus B and negative C. So in this other diagonal, you just introduce a negative. If it was a negative B, you introduce another negative, it will be a positive. So be cognizant of that. Change the positions and introduce negatives on this diagonal. So this is a dummy. Let us now apply it in our matrix. So the determinant is negative 11, so we shall have now the inverse, 1 over negative 11. You can say negative 1 over 11. Then you multiply with and change the matrix. The position of 3 and negative 1 changes. They switch positions. Negative 1 begins here, and of course 3 goes down here. And then introduce negative, negative. So this is negative 2, and this is negative 4. You are not done until the determinant now becomes, 1 over determinant becomes a scalar. So you multiply the scalar by the elements inside the matrix to get that inverse matrix. Is equals to negative 1 over 11 times negative 1 is 1 over 11. Negative 2 times negative 1 over 11 is 2 over 11. Negative 4 times this one, you get 4 over 11. And finally, 3 times this one is negative 3 over 11. So this one is an objective achieved. You have 2 marks. This question will give you 10 marks. The whole of it from the top all the way to the last video. But in this one, when you do the determinants, you have a mark. You do inverse, you have another mark. Even if the question was only 4 marks, you have already gotten 2 marks by doing determinant and inverse. Now we write just one concept, one sentence about determinant and inverse, and then from there we meet in our last video in this chapter. From the concept of determinant and inverse, there is a type of matrix that comes into play, and this is called a singular matrix. A singular matrix. So this is matrix number 4. If you are counting them from the null to the square to the identity to a singular matrix. A singular matrix is a matrix where whose determinant is 0. The determinant is 0. I have shouted there. So if you have, for example, x, 3, 4, and maybe 8, like this, and you are told that this is a singular matrix. Singular matrix. Then it means the determinant of this matrix is 0. Let us try. Main diagonal elements. This is x. This is unknown. By then you will be told to look for the unknown. So let us create a equation. So 8 times x is 8x. Minus 3 times 4 is 12. And because we are saying it is a singular matrix, we shall equate that operation of determinant to 0. So we can say 8x is equals to, take that to the other side, 12 divided by 8 divided by 8. X is equals to by 4 2 by 4 3. This is 1.5. 3 over 2 or 1.5. This is a singular matrix. And for that reason, singular matrices have no inverse. Why? If the determinant is 0, then they don't have any matrix. They don't have any inverse. Because we shall say 1 over determinant 0. 1 over 0 times the interchanging of the values and what have you. The moment you have 1 over 0, you have everything becoming 0. So inverse is not there in a singular matrix. So a singular matrix is a matrix whose determinant is 0, and that matrix does not have an inverse. The knowledge gotten from this video number 3 is going to be used in solving simultaneous equations by the method of matrix. What do I mean? Don't miss in our next lesson. See you.